Green chemistry education, an upstream approach to addressing sustainability challenges. Educating and providing students the opportunity to practice green chemistry allows them to think critically about the environmental impact of their field. We're really pleased today to have three wonderful speakers who've been teaching green chemistry for more than a decade and are leaders in defining and promoting green chemistry education. We will begin the presentation, followed by a 15-minute Q&A session at the very end. Please do post all your questions on the chat window, and we will cover them during the Q&A. We will also post a poll with a few questions from our presenters that you can respond to anytime during the webinar. Your feedback will help us improve the webinars going forward. Poll results will be provided to you after the webinar. All right, green chemistry provides tremendous opportunities for educators to better prepare their students with skills to address global pollution challenges and sustainability through chemistry. This webinar will cover the topic of green chemistry education, covering all levels of curriculum from high school to postgraduate. I'm very excited to introduce and welcome our amazing speakers today. Dr. Wei Zhang is a professor and director of the Center for Green Chemistry at UMass Boston. He was a senior scientist at DuPont and the director of Fluorus Technologies, Inc. His research group is active on green synthesis, organocatalysis, fluorine chemistry, and medicinal chemistry. Welcome, Doctor. Dr. Amy Cannon is the co-founder and executive director of Beyond Benign, a nonprofit organization dedicated to fostering a green chemistry community that empowers educators to transform chemistry education for a sustainable future. Dr. Cannon holds the world's first PhD in green chemistry from the University of Massachusetts, Boston. She brings a background of industrial and academic experience to her work and is passionate about transforming the education pipeline to better support transformative change in the chemical enterprise. Welcome, Doctor. Dr. Lisa Abraham is an associate professor of chemistry at Ambrose University, Calgary, Canada. She teaches general chemistry, organic chemistry, toxicology, pharmacology, nanoscience, and green chemistry courses. Following the growing trend of green chemistry, she is committed to incorporating green chemistry practices into chemistry laboratories with safer chemicals and processes. In addition, she has established a successful undergraduate research program based on green chemistry principles. Together, these are valuable experiences for students, especially for their future careers, as employers are increasingly looking for students who can integrate sustainability with a holistic view of chemistry related to other disciplines. Welcome, Doctor. And now, a few words from our CEO of Viridischem, Neelam Vaidya.
Hello, everyone, and thank you, Nandini. So before we move forward, I would like to introduce two very important people who are making this webinar a success. Nandini Rao, as you just heard from her, she's hosting the webinar and I hope she'll be doing that in future as well. Riddhi Dadda, you cannot see her on this among her face, but she is the person behind all this work. She makes sure all the webinar works well. So today I would like to just share a couple of slides, describe what Viridischem offers, and then give a quick demo that educators, hint on how our product could be used for education. So let me share the screen. Just want to make sure everybody can see it. So Viridischem offers one of the largest highly curated toxicity database with 95 million chemicals, 3 billion properties. That's about 48 properties per chemical. We have a large amount of experimental data that we collected from more than 200 global sources. And we have also, wherever there were data gaps, we have filled it with the in silico data generated using well-known models that industries are using. We have sophisticated toxicity measurement platform that instantly generates in silico data. So as a result, even for the new molecule or postulated molecule, you can get all the properties information as well as the toxicity analysis. It's a unique tool offering toxicity prediction of novel molecules, and it also offers choices of less toxic reagents when you provide your specific reaction needs. So this is our platform. It includes the database, fully automated in silico data generator, and then the analyzer itself. The database contains more than 200 experimental data sources of information. Data gaps are filled with in silico data. We cover 136 different global regulatory lists, and we have in fact translated the textual data from those regulatory lists into digital format, so we can show that, take into account that information when we're doing the toxicity analysis. We have a large SDS repository from reputed sources and the GHSD databases. And every chemical that we have tagged it with its functional groups, its industry use, and how it is used within the different compounds. So based on your specific names and the industry, you can actually select the chemicals that are specific to your industry. As far as the data generator is concerned, we are using industry standard models, and we also have our own read across models that improve the information. And if clients have their own specific models that they would like to use, our platform accommodates that securely and privately. And we also have a deep learning model platform that we are not currently using in the production yet, but hoping to do that soon. As far as the analyzers are concerned, we currently have the chemical analyzer that's available for subscription, and we are right now developing formulation analyzer. So what does it offer to you? The chemical analyzer, if you draw a structure, you get the physical, toxicological, and functional properties. In addition to that, you get the toxicity analysis, both the health, environmental, and safety related. For any known chemical, you can understand the toxicity, regulatory compliance, and GHS classification. You can compare up to 5 chemicals side by side and select the best one. And then based on your reaction needs, you can provide you can get the list of chemicals that match that criteria. And it also provides the toxicity along with the rest of the information. So you can take into account toxicity at level of all levels of your decision making. And these are the number of endpoints that we cover in our analysis. As you can see, ecological, health, and safety, and they are based on number of endpoints. This is all based on ANSI 355 standard, and we are adding more health-related endpoints as we go forward. So having said that, let me actually share with you, give a very quick demo on how the product could be used. So here is our product. I'm going to use thalidomide as an example. As you can see, you can get the information very quickly. All the data that's shown in the green, it's experimental data. When you hover over the values, it shows you the source, where the data is coming from. If it's estimated data, it tells you about the model that's being used. If there are any regulatory concerns, or if the chemical is listed under any regulatory list, if the triangle is yellow or red, when you click on it, it should give you the list of regulatory lists. You can also get the full GHS classification information and the pictogram. When you click on the detail, you get the full information. There are physical properties, toxicological properties, and then there are scores. We currently have a viridiscum analysis, and then we have GHS analysis. So as you can see, the GHS analysis covers, the few endpoints. And as that information becomes available from the manufacturer, then we would be showing that more often. We do update our data very constantly. As soon as the source data gets changed, we get the alert and we update the information. Now let's look at how we can use this to analyze, look at the different molecules. So as you can see, thalidomide structure here, I'm just going to change the structure. And for convenience, I have actually drawn the structure and saved it off so you can actually see it. So as you can see, I have added the amino group here, and it's actually running all the models in the background, and it will be generating the data as we move forward. And this is actually a known chemical. It's analog of thalidomide. Called pomalidomide. So let's actually change the structure even further. And so here, I'm going to remove the oxygen. Sorry. And I'm submitting that query. So now the models are running for both of them. And as you can see, the information is shown very quickly. We have instantaneous execution models. Then this is mainly because we have tagged all our chemicals with all the functional groups, so we can instantaneously identify which models to run to get the information. You can see the detailed analysis by looking at the, each, just by clicking on the point and then look at them. If you don't care to see one of the chemicals and the other one, you can get rid of it. You can bring it back and so forth. And then if you can use this advanced compare information to provide all your reaction criteria and get the list of chemicals that you want to use. So our product is available, there is a free subscription available, limited, that you can try it out and see how the product works. And let us know what you think of it. Thank you. That's it.
Oh, thank you very much, Neelam. I think